We've all held an aluminum can. You finish your drink, maybe you crush it flat, and you toss it in the bin. That crushed piece of metal sitting next to a pile of ordinary dirt hides a relationship that dictates global trade. Aluminum is the single most abundant metal in the Earth's crust. It makes up roughly 8. Take a look at this red dirt, known as bauxite ore. Aluminum doesn't naturally exist as the shiny silver sheets we use in our kitchens. It starts out chemically locked tightly inside this rock. You can't just melt bauxite over a hot fire to get the metal out. To separate the pure aluminum, you have to blast the ore with a massive, continuous electric current at nearly 2,000 degrees Fahrenheit. Because extracting the metal relies on such an extreme, uninterrupted flow of power, the finished aluminum effectively stores the value of the energy used to create it. This creates a unique geographic supply chain. Smelters are rarely built next to the mines. Instead, they appear wherever electricity is cheapest. Look at the massive scale of this hydroelectric dam. High-energy cost nations routinely outsource their aluminum production to countries with abundant, cheap water power, like Canada or Iceland, because the power bill is the single biggest hurdle to making a profit. Compare that to these active smokestacks. Today, China dominates global production, producing over a third of the world's supply by relying heavily on cheap but highly polluting coal-fired power plants. When traders buy and sell aluminum futures in London or Shanghai, they are effectively bypassing the physical metal. They're trading a proxy for the cost of global electricity, which brings us back down to the consumer level and your kitchen recycling bin. You might have noticed that local scrap yards and recycling centers are always eager to pay cash for empty cans. Here's the math behind that transaction. Melting down an aluminum can that already exists takes only 5 to 10% of the energy required to extract new metal from bauxite ore. By skipping the most power-hungry step of the process, recycled metal becomes much cheaper to produce than raw extraction. When you see an industrial operation like this, endless belt of crushed cans, you are looking at a pure economic response. The financial incentive is so strong that roughly half of the world's total aluminum supply now comes entirely from melted scrap. Recycling an empty soda can helps the environment, but in global commodities markets, it's a pure financial shortcut, bypassing high energy costs. If making brand new aluminum is so expensive and energy hungry, why is global demand continuing to climb? The answer lies in its unmatched strength-to-weight ratio. If you look closely at the riveted exterior of a commercial airplane, you're looking at specialized aluminum alloys. The aerospace industry relies on this lightness because shaving off even a tiny fraction of a plane's weight saves massive amounts of aviation fuel over a 30-year lifespan. And if we examine the exposed structural frame of this modern car, we see the auto industry following suit. Manufacturers use aluminum in Alentith vehicles to offset the weight of heavy batteries, which directly extends how far the car can drive on a single charge. This creates a difficult irony. We need this lightweight metal to build the green, fuel-efficient cars that reduce our carbon footprint, yet the majority of new aluminum is still produced in plants powered by coal. As governments and consumers track these emissions, the market has started pricing aluminum differently. Many buyers now pay a green premium, a higher price specifically for metal refined with wind, solar, or water power. So the next time you pop open a beverage, remember what you're actually holding. That thin, shiny shell is a physical manifestation of the global energy grid, connecting your local recycling bin to international power markets and the future of transportation.